Good morning, class. Welcome back once again to your Planning 3 subject, Introduction to Urban and Regional Planning. So, in continuation with our subject, today we'll explore how human settlements and buildings take shape. Just like how living organisms grow and adapt, our homes, rooms, and cities also evolve over time. So this process is called morphogenesis. This is going to be one of our topics for today's session. It's about how spaces, whether small like a room or large city, are formed, organized, and improved to fit human needs. We'll also see how early shelters started simple, then became connected, and eventually transformed into efficient, well planned spaces. So, by studying this, we can understand not just architecture, but also the science of human settlements or ecologistics. That's going to be also one of the topics for today's session. So, this will help us see the link between biology and architecture and how both follow patterns of growth and adaptation. So, as we go through the topics, the diagrams, I want you to think, how do our spaces today reflect this evolution, and how can we design for better living in the future? So, ready your notebooks for taking down notes for today's topics. And before we begin with our topic, I will give you a few minutes to think about this question. You write this question on your notebooks, and then you write also your answers below the question, and I will be checking your answers as I go along with checking your notebooks by the end of the midterm grading period. Okay, requirement man ninyo as your one of your PIT for this subject. Okay, so you write down this question and answer for a few minutes. The question is, if you were to design the first room ever built, what shape would it be and why? So again, the question is, if you were to design the first room ever built, what shape would it be and why? I will give you 3 minutes to answer that question and just provide a quick and brief answer to the question right there in your notebooks. Okay, so let's continue. I hope you are done answering with the questions I gave you. Let's proceed. Our first topic for today is about ecologistics. So ecologistics class is science of human settlements. Ecologistics involves the descriptive study of all kinds of human settlements and the formulation of general conclusions aimed at achieving harmony between the inhabitants of a settlement and their physical and social cultural environments. Descriptive study involves the examination of the content, such as man alone or in societies, of a settlement and the settlement container or the physical settlement, composed of natural and human made elements. This definition is from the Britannica Encyclopedia. Acoustics basically means the science of human settlements, how people live together in places. So it studies all types of settlements from small villages to big cities. Its goal is to create harmony between people and their environment. Both the physical environment like atong pasabot ana, the land, buildings, roads, and nature, and the social cultural environment like traditions, cultures, and community life. So when studying settlements, ecologistics looks at two main parts: the content, which means the people who live there, and the container, which is the physical settlement. The physical settlement itself means natural features like rivers, hills, and forests, plus human-made elements like houses, streets, and utilities. So in short, ecologistics is equal to the people and their homes or their communities, plus their environment, all working together in balance. Okay, so here is a synopsis or a general idea about acoustics. So, can you read it with me? In order to create the cities of the future, we need to systematically develop a science of human settlements. This science, termed acoustics, will take into consideration the principles man takes into account when building his settlements, as well as the evolution of human settlements through history in terms of size and quality. The target is to build the city of optimum size, that is, a city which respects human dimensions. Since there is no point in resisting development, we should try to accommodate technological evolution and the needs of man within the same settlement. So here's a simple explanation of this synopsis. No, so you to build better cities for the future, we need a science of human settlements called ecostix. Ecostix studies how humans create settlements like villages, towns, cities, and how these have grown and changed over time in terms of size, whether from small to large, and quality, it's from simple or to more advanced. The goal here is to design a city of the right size, not too big, not too small, where people can live comfortably and in balance with their environment. So instead of fighting against development and technology, since dinha na magita padulong, Ecostix suggests we should work with them, making sure both human needs and technological progress fit together in one settlement. So, in short, class, Ecostix helps us design future cities that are human friendly, balanced in size, and adaptable to technology and growth. This is Konstantinos A. Doxiadis, or famously known as C.A. Doxiadis. He is the father of Ecostix. Konstantinos A. Doxiadis, born on May 14, 1913, and died on June 8, 1975. He is considered the father of echystics. The term echystics was coined by Doxiadis in 1942, and a major incentive for the development of the science is the emergence of increasingly large and complex settlements, tending to regional conurbations and even to a worldwide city. However, echystics attempt to encompass all scales of human habitation and seeks to learn from the archaeological and historical record by looking not only at great cities, but as much as possible at the total settlement pattern. Doxiadis also coined the term entopia, coming from the Greek word in and top, meaning place. He quoted, "What human beings need is not utopia, no place, but entopia, in place. A real city which they can build, a place which satisfies the dreamer and is acceptable to the scientist, a place where the projections of the artist and the builder merge." So acoustics, the word acoustics came from the Greek word oikos, meaning a house or a dwelling. So it is the science of human settlements. It coordinates economics, social sciences, political and administrative sciences, technology and aesthetics into a coherent whole, and leads to the creation of a new type of human habitat. The definition was coined by Doxiadis in 1963. So here's an image of C.A. Doxiadis explaining his plan for the streets of Rio de Janeiro. Okay, so this image right here explains the concept of acoustics developed by C.A. Doxiadis. It shows the five interconnected elements that make up and influence every human settlement, which refers to the people or individuals. This is the central element of settlements. It it also refers to human needs, behaviors, and aspirations as the starting point of planning. And the second element is the society. This is the organized structure of people. This pertains to families, communities, institutions, or culture. So this reflects social interactions, governance, and shared identity. The third element is nature. This is the natural environment, land, water, climate, flora, fauna, and geography. This is the this means that settlements must adapt to and coexist with nature. Fourth element is the shells, or this refers to the building or the shelter. So this is the physical structures where people live, work, and interact. So this refers to homes, offices, and infrastructures. So this element provides safety, comfort, and functionality. Fifth is the networks. This refers to infrastructures or connections. So these are the systems that connect people and activities. So this particularly refers to transportation, communication, utilities, and energy. So this element enables mobility, access, and flow of resources. So and the lines between each circle represent the interconnectedness of all five elements. So for a settlement to function well, these five must be balanced and integrated. So for example, a growing city needs more shells or more housing, better networks or transportations, careful management of nature or environmental sustainability, and alignment with human needs. So in summary, or in short, class in totality, the diagram shows that a human settlement is not just about buildings or people alone. It is a dynamic system of people, society, nature, shelter, and network, all interacting continuously. Okay, so here's a simple analogy of ekistics that can easily be remembered. So analogy meaning similarity, no, of uh ekistics. So for example, a house, it is similar a house as a human settlement. So in a house, the five elements of ekistics is also present. So firstly is the man or the people, no? This pertains to the residents of the house. So without people, the house has no purpose. Second element is the society. So this pertains to the family living inside the house. So aside from individual people, there is family. So they set the rules, they share culture, and they create relationships. The third element is nature. So this pertains to the land, sunlight, water, and climate around the house. So the house must adapt to the environment. For example, if the house is near the river or on top of a mountain, or the house is prone to typhoons, so it must adapt to the existing environment. Fourth element is the shelter. So this pertains to the house or the building itself. So this provides safety, comfort, and space for daily life. And lastly, networks. So this pertains to the connections and utilities. For example, the roads, electricity, water, internet. So these networks allow people inside the house to connect with the wider world. So in summary, a house or a house as an example of a human settlement works well only if all five parts exist and support each other. You can't just have a building or a shell without people, or people without networks, and society cannot you can't just have a building or a shell without people or without network or without society. So the five principles of man in shaping his settlements. So first principle is maximization of man's potential contacts with elements of nature, with other people, and with the works of man. Second, minimization of the effort required for the achievement of man's actual and potential contacts. Third, optimization of man's protective space. the selection of distance to contacts, show in example walls, fortifications, etc. Optimization of the quality of man's relationship with his environment, or the influence in architecture and arts. Fifth principle is organizes his settlements in an attempt to achieve an optimum synthesis of other four principles. Energy models. So the definition of energy models, these are representations of how people and settlements use energy in their daily lives. They show the relationship between energy sources, so that's human power, from where the energy came from human power, animal power, fossil fuels, electricity, and also settlement patterns. These are, for example, the settlement pattern of compact villages versus spread out or suburbs, and activities like farming, transportation, housing, and production. So, energy models explain how energy availability and technology shape the way cities and villages are built, connected, and function. So, this image shows energy models in acoustics and how energy use changes as societies evolve. On the left image represents an early agricultural society transitioning from hunting to gathering to farming. So the lines show random movements of people as they search for food and cultivate land. So energy is consumed mainly for basic survival, like walking, hunting, small scale farming. So their daily capita energy consumption is 3,000 calories, which is close to what human needs for physical labor. So this stage shows low organization and scattered activity across the land. On the right image, this is an energy model of a village with daily per capita energy consumption of 8,000 calories. So this represents a settled agricultural village. The pattern looks structured like branching veins, no, showing organized agricultural fields radiating from a central settlement. So energy is consumed in two ways here. Agricultural for the fields, energy spent in farming the land, and second is the village life. So the energy is spent on housing, cooking, community tasks, and daily activities. Daily per capita energy consumption rises to 8,000 calories, reflecting more complex work, greater productivity, and social activities. So, this stage shows higher organization, stable settlements, and division of labor. So, these two models illustrate the evolution of energy use in human settlements from scattered survival focused movements by hunters or farmers to organized high energy structured villages. So as the societies progress, they require more energy to sustain larger populations and more complex systems. Another example of an energy model shows two energy models of central settlements and surrounding villages that compare how energy consumption and mobility patterns differ between a pre-automobile society and an automobile society. On the left, which is Model A, this is the pre-automobile society with daily per capita energy consumption of 12,000 calories per person per day. So energy use here is limited to human and animal labor only. Settlements are compact and walkable. Agriculture dominates energy use, and villages cluster close to the central town. In Model B, this is the energy model of the central settlement of a system of villages during the era of the automobile. This is the time where there are already cars and other automobile types. So their daily per capita energy consumption is rises to 25,000 calories per person per day. So the energy consumption came from fossil fuels and cars, no? The settlements spread out like suburbs or sprawl. transportation becomes a major energy user. People can live farther from work and markets since automobiles are accessible. So in connection to urban planning, energy models are useful in planning because they show how energy availability determines city size, density, and transport systems. Energy models are also useful in planning because they show why compact cities are more energy efficient and sustainable. And also, energy models are useful in planning because they show the risks of high energy, car dependent cities like pollution, sprawl, and inequality. So, energy models are tools to understand how energy use influences the growth, form, and sustainability of human settlements. Okay, so the three diagrams here show how energy use increases over time and how it changes the way villages and cities function. On the leftmost image is a human settlement having 25,000 calories per person per day. So energy use is still moderate. People rely on human energy and some fossil fuels like cars and machines. Settlements are more spread out than before, but agriculture is still visible. So this reflects the early automobile era. In the middle is a human settlement with consumption of 45,000 calories per person per day. So there is much higher energy use because during this time, there is already a growth in the industry and transportation. Naanay, there are presence of cars, machines, and factories. They dominate the industry. And also here, villages tend to expand and the central town becomes more connected with wider roads and commercial activity. And slowly, agriculture is shrinking in comparison to the left image. On the right is a human settlement with consumption of 100,000 calories per person per day. So there is very high energy use here because it is already industrialized and modern city. There's heavy reliance on commercial energy like electricity, oil, and industry. And it shows that agriculture almost disappears from the map and the city becomes dense, industrialized, and energy intensive. So as you zoom in on the image, hopefully maklaro ra ninyo, there are legends representing what is inside the images provided. But a simple takeaway for the comparison of these three images is that more energy means the settlement is more spread out, it is more industrialized and car dependent cities. Less energy means a compact settlement, a reliance on agricultural, and the villages are only walkable. So the model shows how urban form shaped by how much energy people use. So in short, these diagrams show the evolution from traditional villages to automobile-based towns to fully industrialized cities with energy use multiplying at each stage. Okay, human settlements evolution. This is the explanation of how human settlements began, factor which defines the extent of human settlements, the distance man wants to go or can go in the course of his daily life. In each specific case, the process starts with the circle whose radius is defined by man's willingness to walk daily up to a certain distance, and to spend a certain period of time in doing so. The limit for the rural dweller is 1 hour or 5 kilometers for horizontal movement. The limit for the urban dweller is 20 minutes or 1 kilometer. This leads to the conception of a circular city and of a city growing in concentric circles. When the machine, for example, the motor vehicle, enters the picture, we are gradually led towards a two-speed system and then toward interconnected settlements. Then the road toward larger systems, the universal city of Ecomenopolis, is inevitable. This is the explanation of how human settlements began. The key factor is that the size of a settlement depends on how far people are willing to travel in their daily lives to work, to shop, to school, etc. So in the past, people usually moved around by walking. So for rural dwellers, the limit was about 1 hour or 5 kilometers. For urban dwellers, it was shorter, about 20 minutes or 1 kilometer. So this is why early settlements formed circular shapes and grew in concentric circles around a center like a marketplace or a town square. And also, there is a big impact of technology. So when machines like cars appeared, people could travel farther and faster. So this created a two-speed system. So walking distances for nearby activities and vehicle for farther places. Settlements began to interconnect, leading to bigger cities and eventually the concept of a global city or ecomenopolis, a continuous urban settlement covering the world. Okay, this slide shows how human settlements evolve over time as movement or mobility changes from walking to using machines like cars. So the explanation of each stage, A and B images shows pedestrian only growth. So settlements are small and close together. People rely only on walking. There we can see pedestrian kinetic fields connecting the circles. Villages or small sta- villages or small towns stay compact because people cannot travel far. Images C and D, this is pedestrian plus mechanical growth. So ex- settlements expand as mechanical transport like cars, carts, trains, etc. is introduced. So as you can see, the circles have outlines representing the expansion of settlements. As mechanical transport is introduced, there is the presence of cars, trains, etc. And the kinetic fields, the lines, this pertains to the areas people can reach became larger. The towns grow along roads and transport lines, not just around walkable centers. On the images E and F, so these are large systems with both pedestrian and mechanical fields. So the settlements connect into a network of cities and towns. People live farther from the center because transportation allows longer travel. Cities grow outward, forming corridors and metropolitan regions. So this is the stage of modern urban sprawl and regional cities. So simple takeaway from this image is that uh, human settlements, like walking settlements, means compact and small villages. And then settlements with transport settlements extend or expand. So they became towns and so they became towns or cities. They grow bigger. And also with advanced transport, settlements interconnect. So the cities, the towns became regions and metro areas. So this diagram basically shows the transition from village to town to interconnected city systems, shaped by how people move through walking and transport. Human settlements evolution. Throughout the long evolution of human settlements, people in all parts of the world tended to build an urban settlement which reached an optimum size of 50,000 people and physical dimensions such that everyone was within a 10-minute distance from the center. It says here that in history or before, many urban settlements naturally grew to about 50,000 people. So this is just the optimum size of a normal settlement. So this size allowed the city to function well without becoming overcrowded or too spread out. Next is for people who depend on walking as a means of locomotion, this unit is the optimum one from the point of view of movement and social interaction through direct contacts between people. So this now here refers to accessibility. So the physical layout was such that everyone could reach the city center within 10 minutes by walking. It also explains here the accessibility. No? So the physical layout was such that everyone could reach the city center within 10 minutes by walking. This meant that settlement was compact and people could easily interact with each other. So, for people who depend on walking as a means of locomotion, this unit is the optimum one from the point of view of movement and social interaction through direct contacts between people. So, since people mostly walked, this size was ideal for daily life, the optimum size, which is 50,000 people. So it encouraged social interaction because people could meet, trade, and communicate directly without needing vehicles. So this is an image human settlements evolved. In the past, which is in the left image, settlements were small and local. So people lived in small communities where everyone had equal opportunities to interact and connect with others around them. The social world was limited but fair and balanced. As you can see on the image, they're equal sparkles. It's like equal sparkles, no? So everyone had equal opportunities to interact and connect with others around them. The social world was limited but fair and balanced because choices were similar for everyone. In the present or modern world, which is the image on the right, shows larger cities and advanced transportation or communication. Some people have many more opportunities, lots of connections reaching far away, but at the same time, others may have very few choices and are left out. So this creates unequal access up so this creates unequal access to opportunities. Some people are highly connected while others remain isolated. So in simple terms, before, everyone had a small but equal chance to connect, but now some people can connect widely, many choices, while others are stuck with very limited options. So that's how human settlements evolved. Another diagram showing human settlements evolution. So in the on the left of this image is the first phase of organization. No, it shows the early stage of settlements. People from small dwelling groups, clusters, uh, people from dwelling groups, like clusters of houses. These clusters are somewhat connected but not yet fully organized. There is basic efficiency in how space and time are used, but still some disorder. On the right image uh, is toward organization of a dwelling group unit. This is the third phase of organization. It shows a more advanced stage of settlements. There is order and structure and function. Settlements are planned better. The connections between groups are clearer, creating a system where space and time are used more efficiently. This also reflects planned urban growth where everything is arranged to achieve maximum efficiency. So, in simple terms, class, on the left, settlements are starting to form, organized in small groups but still rough. On the right, settlements are fully organized. They are well structured, efficient, and orderly. Hierarchy of settlements. So this slide is showing the ekistic logarithmic scale, which explains how human settlements are organized in a hierarchy. So from the smallest unit, which is the individual person or the anthropos, to the largest, which is the whole world as one city. So this is what the table comprises of. There's the ekistic units. So these are the 15 levels of settlement shown on the first row. So each level represents a larger scale of human organization measured by population size and area covered. Next is the community class. So each level also corresponds to a community class. Level 1 to 12, which shows how many people typically live in that type of settlement. For example, class 1 is just one person, while class 12 is the entire world population. Next is the kinetic field. So these are the activity zones represented by letters A, small letters A, B, C, so on and so forth, to big letter H, in which these are the activity zones in which people live and interact. So it refers to the function and movement of people inside each settlement, like house, neighborhood, city, etc. And there's name of unit and population at the bottom, which their typical population ranges from anthropos to one person. Room is composed of a space for one person. House composed of a family unit of equal or less than 5 people. House group equal to or less than 40 people. Uh, there's a neighborhood of composed of 500 to 2,000 people. Small community composed of 8,000 people. City, or in other words, polis, is equal to or less than 50,000 people. Metropolis is equal to or less than 5 million people. Megapolis is equal to or less than 50 million people. And lastly, Ecomenopolis is equal to or less than 50 billion people. This is the whole world interconnected as one global city. So, according to this scale, settlements grow in scale logarithmically. Each level is about 10 times larger than the previous. So, this scale right here helps planners understand how human needs, services, and infrastructure change as the population grows. For example, at a neighborhood scale, no people need schools and small markets. At the city scale of 50,000 people, people will need universities, hospitals, and airports. At the megapolis or the world scale, there will be presence of issues including climate change, global trade, and transportation networks. So basically, this chart shows how settlements evolve from the smallest unit of one person to the largest unit of the world as one city, and how population size affects planning needs. So this is the population figures. This was created by Doxiadis. Next is a diagram showing the percentage of built-up areas in the 12 land zones. So this is a chart from Ekistics showing how the Earth's land is divided into different zones of use. The vertical axis on the left refers to the percent of global land area. So 100% at the top going down. The horizontal axis refers to the percent of built up area in each zone. So how much is occupied this in short, how much is occupied by human activities. So the zones 1 to 12 represent categories of land from natural areas to highly urbanized industrial areas. So the zones here explained, okay, let's explain one by one the zones here. So in zone 1, having 40%, meaning there's still natural areas, untouched areas like forests, deserts, and mountains. Zone 2, having 17%, meaning there is more natural land, lightly modified by humans, woodlands, savannas. Zone 3, 10%, is cultivated farmland. So there is a presence of agriculture or grazing. Zone 4, having 8%, is semi-natural mixed land. So there's agriculture plus small settlements. And zone 5 to 6, composed of 5% each. So these are rural villages and small human settlements with farming. Zone 8, 3%. So there's larger towns. Zone 9, 1.3%, small cities. Zone 10, 0.7%, larger cities. And Zone 11, 0.3%, large metropolitan areas. And almost completely natural areas are disappearing. Basically, it explains class that zones 1 to 4, the majority of the Earth's land, like zones 1 to 4, is still natural or rural land. And only a very small fraction of land, like zones 10 to 12, that's less than 1%, is occupied by big cities and industries. But these areas hold the largest populations and highest activity. And this shows the diagram shows the imbalance between land use and human activity. This means humans cluster heavily in small urban zones, leaving vast rural natural areas with fewer people. This diagram is about the hierarchy of settlements within the ekistic logarithmic scale, which explains how human settlements grow and connect into larger systems over time. The image illustrates the structural identity of large-scale settlements, so how smaller settlements like villages, towns, cities merge and evolve into bigger and more complex systems. It focuses on the upper levels of the hierarchy: large city, metropolis, conurbation, megapolis, urbanized region, ecomenopolis. So in the diagram, so there are levels here like ELS 9. This is for large city, a single large urban center that dominates its region. ELS 10, the metropolis, so a cluster of large cities connected by strong transport, trade, and cultural ties. ELS 11 is conurbation, so there's continuous urban growth where multiple cities physically merge into one extended urban area. ELS 12, this one is the megapolis. So even larger several conurbations or metropolitan regions link together, often along major corridors. So example of a megapolis is, if you can search this out, no, is Boston, Washington in the United States. And next is the ELS 13. So this is urbanized region. There are multiple megapolises connected into vast urbanized areas across regions. In ELS 14, this is urbanized, that's or ELS 13 to 14. In ELS 15, this is the ultimate vision of Doxiadis, which is the Ecomenopolis. This is a single, continuous city covering the habitable world, interconnected by technology and infrastructure. So why this uh, diagram matters in urban planning? No? Why does this diagram of hierarchy of settlements matter in urban planning? Because it shows urban growth patterns. So from small settlements don't stay isolated forever. They grow, connect, and merge into massive networks. And this also matters in urban planning because it predicts future challenges. As cities expand, issues of transport, governance, resources, and sustainability become regional and even global. Also, the hierarchy of settlements guides planning. It helps planners prepare for regional integration. No, they can prepare for transport systems, shared resources, and environmental protection. Okay, this slide is about the future vision of human settlements called Ecomenopolis or the Universal City. This is a vision of Doxiadis, no? What the diagram shows here is that a world map projection with shadings to represent different levels of urban density, from high, medium to low. So it visualizes the probable structure of Ecomenopolis as imagined by Constantinos Doxiadis around the year 2100, with a projected population of 15 billion people. The idea is that as population grows and settlements merge, the entire Earth could become one continuous, interconnected urban settlement. So is that the key concept is ecomenopolis from oikomen, meaning inhabited world, and polis, meaning city. So it basically means a single global city. So Doxiadis envisioned that by 2100, high density urbanization would cover large parts of Europe, East Asia, South Asia, and North America. And then medium density zones would fill much of Africa, Latin America, and parts of Oceania. And then few low density or untouched areas would remain. So the world's infrastructure, transport, and digital networks would connect all regions into one global system of habitation. So why this vision of Doxiadis matters for us, no? Because it matters because aside from it being visionary, it is also cautionary. So it's not just predicting growth, but warning about overpopulation and urban sprawl on a planetary scale. Also, this matters because this presents global planning challenges. So, food, water, energy, housing, and climate issues would need to be solved at a global governance level. And lastly, this matters because of technology and globalization. So already today, with the internet, trade, and megacities, we see the first step toward an eco-monopolist. So with our technology today, it looks like we are really going to become uh, an eco-monopolist, no? So in short, this map is a illustration of a future scenario where Earth itself functions like one giant city, connecting 15 billion people into a single urban fabric. So, medyo scary siya, no? Next is this diagram introduces the idea of ecomenokepos, which means the global garden, and shows how it could be combined with a vision of ecomenopolis, the universal city covering the earth. So what is ecomenokepos? It is the concept of linking all open spaces and natural areas on earth into one continuous global system. So imagine green corridors, parks, forests, rivers, and protected lands connected across regions and continents. So how does this relate to Ecomonopolis or the world city? So Ecomonopolis imagines the earth as one continuous city with billions of people. Then Ecomenokapos ensures that nature is not lost in urbanization. So the global garden would run through and around cities so humans and nature can coexist. So why is this important? Why is Ecomenocapos important? Because uh, there is environmental balance. It prevents total urban growth from or urban sprawl from destroying ecosystems. It is important for our human well-being. No, green spaces, we all know green spaces improve air quality, health, and recreation. It is also important for our biodiversity corridors. Wildlife can move and survive even in a highly urbanized planet if this can be realized. And lastly, it is important because it helps in sustainability. It ensures that future settlements respect both human needs and the planet's ecological systems. So while Ecomenopolis imagines a fully urbanized world, Ecomenocapos makes sure that within this world city, there are continuous green networks, a global garden, so nature and humanity grow together. So this is another uh, image representation of the Ecomenocapos, no, inside the Ecomenopolis. Okay, next topic is about morphogenesis. So, according to the Britannica Encyclopedia, the shaping of an organism by embryologic processes of differentiation of cells, tissues, and organs, and the development of organ systems according to the genetic blueprint of the potential organism and environmental conditions. So the word morphogenesis class originated from the field biology. So in biology, morphogenesis refers to how organisms develop their shapes, structures, and organs through genetic and environmental influences. It's like the blueprint that guides growth. Morphogenesis in human settlements varies with the type of unit we are dealing with. We do not know how and when the formation of a room started. It probably started in many parts of the world, and probably the rooms had many forms and sizes. We have reason to believe that the first rooms were of moderate size according to today's standards, but they may have been very small or one man, one night huts similar in a way to those built and used by apes. Applied to human settlements, in urban and architectural terms, morphogenesis refers to how human settlements buildings, and spaces evolve in form. So this paragraph here suggests that the earliest rooms or shelters humans made likely began in different ways across the world, taking on various shapes and sizes. It also explains here the early forms of rooms. Some may have been moderate sized enclosures by today's standards, others may have been small, temporary huts similar to those built by apes, indicating a primitive stage of architectural forms. In short, this this is drawing a parallel comparison between how biological forms grow, guided by genes and environment, and how human settlements or rooms take shape, guided by needs, environment, and available resources. So the topic morphogenesis connects to echystics in the following way. So in morphogenesis and echystics, they share the concept of growth and form. So just as morphogenesis in biology explains how living organisms develop form and structure, echystics looks at how settlements like villages, towns, cities grow and transform their form over time. Both are about patterns of development. One is in biology and the other is in human environments. They also they are also connected in ways as blueprint and environmental influence. So morphogenesis is guided by a genetic blueprint plus environmental conditions. Similarly, in echystics, the growth of settlements is guided by human needs. But for example, the shelter, economy, social life, plus environmental factors such as geography, climate, and resources. Also, morphogenesis and echystics are similar because of the connection to the hierarchy of settlements. So, morphogenesis explains the origin and shaping of the smallest units. Echystics then builds on this idea by analyzing how these units interconnect and scale up into a global network of settlements. So in summary, class, morphogenesis provides the biological analogy and starting point for understanding the shaping of human settlements, while echystics expand this into a systematic science of how settlements grow, organize, and interact at every scale. So here's a simplified comparison or diagram of morphogenesis, biology, and human settlements echystics. So in morphogenesis, there is cell, which is the basic unit of an organism. And in echystics, that is equivalent to a room. Now, in biology, group of cells become tissues. And in echystics, several rooms is equivalent to a house. In biology, an organ is composed of different tissues. And in echystics, a neighborhood is composed of several houses forming a larger functional unit. Next is in morphogenesis in biology, there is an organ system which is composed of an entire system that is composed of different organs. And in echystics, there is a city which is composed of different neighborhoods integrated into one system. And lastly, in biology, there is organism, which is composed of different organ systems. And in echystics, there is ecomenopolis, which is the global city, the complete living system of human settlements. So this shows how echystics borrows the concept of growth and organization from biology, seeing human settlements as living organisms that evolve from simple to complex forms. So this right here explains the morphogenesis of walls. So how walls evolved, no, in relation to human settlements and architecture, showing how the form of walls evolved based on human needs, proportions, and practical use of space. So during the early times, early shelters followed the natural human scale, which is ahan nagikan ang concept of organic architecture, no? So the curved or domed walls shown on the left illustrate how shelters first developed in response to the human body's dimensions and sensory comfort. So the consideration here was the height, sight, reach, and protection. The curved walls on the left, while visually natural, they often create wasted space when integrating furniture and functional layout. So furniture, which is usually straight-edged, doesn't fit efficiently into curved enclosures. On the right, which is the straight walls, this allows for the most economic synthesis of room design. So, furniture placement and circulation. Rectangular layouts make it easier to organize human activities and objects without wasting space. So, in connection to acoustics, morphogenesis here shows how human settlements and buildings evolved not only from cultural and social needs, but also from biological proportions and efficiency. So the shift from organic, curved forms to rectilinear, geometric structures demonstrates the pursuit of practicality and economy in settlement design. So the highlight of the diagram here is that architecture adapts from human biology but matures through functional efficiency, which is a recurring theme in acoustics. No? Settlements evolve like organisms shaped by necessity and optimization. Okay, this is about morphogenesis of rooms. So, how the spatial relationship and connection between rooms evolve to maximize efficiency and comfort in human settlements. So the explanation here is that on the left, there are two separate non-connected rooms. These rooms are independent and can function separately. However, people tend to create connections between them for convenience, like doors or shared walls. This shows the natural human tendency to link spaces for easier use. In the middle, there's two separate but connected rooms. When two round or curved rooms are connected directly, they lose independence and create problematic surfaces. There is awkward overlaps, wasted space, irregular boundaries. So this stage shows that simply joining spaces without proper planning can lead to inefficiency. On the right are two connected rooms optimized. So here, the problem surfaces are eliminated through better geometric organization. There's square or rectangular forms. So connected rooms become more efficient, occupying minimum total area while still functioning as distinct but related units. This represents the evolution toward rational planning of interiors. So the connection of this image to acoustics, just as settlements grow from scattered huts into organized village, rooms evolve from isolated spaces into integrated, efficient units. The process reflects optimization of space, function, and human movement, which is central to the science of settlements. So let's stress this out that during the earlier times, early shelters were separated and irregular. On mid-stage, connections are created inefficiencies, and on modern settlements and buildings, they strive for integration with minimal wasted space. Okay, so that's about morphogenesis of rooms or how the spatial relationship and connection between rooms evolve to maximize efficiency and comfort in human settlements. Okay, so that's about it for today's session. And to close this lecture, no, as we've seen and as we've learned, the growth of human settlements from the smallest room to the vast global city, it is not random. So it follows patterns, much like how living organisms grow and adapt. So this connection between morphogenesis and acoustics reminds us that every space we design should respond to both human needs and the environment. So as future architects and planners, our challenge is to continue this evolution consciously, to design spaces that are functional, humane, and sustainable. So remember, cities are living systems and we are the caretakers. Okay, so if you have questions with regards to the topics that we've discussed today, kindly send me a message through our group chat or through email so that I can address your questions individually. And I hope that I have delivered the topics well and you have understood the topics that we've discussed and that it would help you understand more about the subject urban and regional planning. Thank you for listening and for learning. We will see each other on the next class. Goodbye.